Hello everyone, welcome to Red Shikshan Sanstha's Western Region YouTube channel. We will study through video series every day. The different subjects, staying at home, being safe. Today we are going to continue learning of lesson number 1, Laws of Motion from subject Science and Technology part 1. In the last video, we have learnt about motion, displacement and distance, speed and velocity, types of motion, acceleration and types of acceleration. Let us begin with today's topic, distance time graph for uniform motion. What is uniform motion? Yes, we have learnt in last video, when an object covers equal distances in equal intervals of time, it is said to be in uniform motion. When we try to plot a graph between distance and time for uniform motion, then what will be its nature? Let us understand it from an example. The following table shows the distances covered by a car in a fixed time interval of 10 seconds. And when a graph is drawn of a distance against time by taking the time along the x-axis and distance along the y-axis, then the graph between distance and time is a straight line, as shown in the alongside graph, because in uniform motion object covers equal distances in equal intervals of time. Now let us understand the distance time graph for non-uniform motion. When an object covers unequal distances in equal intervals of time is said to be in non-uniform motion. When we try to plot a graph between distance and time for non-uniform motion, then let us see it has the same nature as like uniform motion or not. For getting the answer of above question, we will go through an example. The following table shows the distances covered by a bus in fixed time interval of 5 seconds. And when a graph is drawn of a distance against time by taking the time along the x-axis and distance along the y-axis, then the graph does not show direct proportionality between distance and time. As in non-uniform motion, the object changes distances non-uniformly with the time. Now let us move ahead with the another topic, velocity time graph for uniform velocity. Consider a train is moving with uniform velocity of 60 km per hour for 5 hours continuously. Then the variation of velocity and time can be represented by velocity time graph. When we plot a graph by representing time along the x-axis and velocity along the y-axis, then we get a straight line parallel to the x-axis as shown in the next graph. When an object is moving along a straight line, then we can find the distance covered by it if we know its velocity and time. So we get clear from the following two questions how to determine the distance covered by moving object. Question first. With the help of graph, how will you determine the distance covered by train between 2nd and 4th hours? We know that velocity is equal to displacement upon time, but in linear motion the values of distance and displacement are same. Hence velocity is equal to distance upon time we can take here, and from this we get distance is equal to velocity into time. After putting the values of velocity and time, we get s is equal to 60 into bracket 4 minus 2 bracket complete, which is equals to 60 into 2, and finally we get s is equal to 120 kilometers. This is the first way to determine the distance covered by an object using formula. The second question Is there a relation between distance covered by the train between second and fourth hours and the area of particular quadrangle in the graph? Yes, both are related to each other and the values are same. What is the acceleration of the train? So let us see that the distance covered is equal to nothing but the area of quadrangle ABCD. Here the quadrangle ABCD is the rectangle. So therefore we can take area of a rectangle ABCD is equal to length into breadth equals to 60 into 2, and finally we get area of quadrangle is equal to 120 kilometer, which is also equals to the distance covered by moving object. And the value of acceleration of the train here is 0 because the initial velocity and final velocity both are the same. After this, we are going to find about nature of velocity time graph for uniform acceleration. In uniform acceleration, the velocity changes by equal amounts in equal time intervals, that is uniformly accelerated motion. Hence, if a graph is drawn of velocity against time by taking time along the x-axis and velocity along the y-axis, then the nature of graph is a straight line. But for non-uniformly accelerated motion, the velocity time graph may have any shape depending on how the acceleration changes with time. Based upon it, we have an example. The alongside table represents changes in the velocities shown by a car in fixed time interval of 5 seconds. How we have learned to determine the distance covered by an object for uniform velocity, in the same way we can determine the distance here too using formula and using graph. So let us find the distance covered by a car between 10th and 20th second using formula. From the graph we get on 10th second velocity is 16 meter per second and on 20th second velocity is 32 meter per second. And their average is 16 plus 32 divided by 2, which is equals to 24 meter per second. Hence we get V is equal to 24 meter per second, time is equal to 10 seconds. Also we know that velocity is equal to distance upon time, and therefore distance is equal to velocity into time. So after putting the values of velocity and time in the above formula, we get distance is equal to 240 meters. Also the value of distance covered by the train we can get by finding the area of quadrangle ABCD. Here quadrangle ABCD is made of a rectangle and a triangle. Therefore area of quadrangle ABCD is equal to area of rectangle AECD plus area of triangle ABE, which is equals to AD into DC plus half inside the bracket BE into AE bracket complete. After putting the values for all these things, we get 16 into 10 plus half into the bracket 16 into 10 bracket complete, which is equals to 160 plus 80, and finally we get the area of quadrangle ABCD equals to 240 meter, which is equals to the distance covered which we got from the formula. So here we got the same values for distance using formula as well as using the graph. If you like this video, please press the like button, also subscribe the channel, and don't forget to press the bell icon for more such informative videos. Revise the learning at your own comfortable time. We will interact again with you in the next video. Till then, enjoy learning. Thank you.